So something special happens when vectors are orthogonal. Orthogonal is a fancy way of just saying perpendicular. And perpendicular just means they are 90 degrees. They hit at a perfect right angle. Now the reason we have this is because in 2 dimensions, having a 90-degree angle like that is perpendicular. But sometimes in 3 dimensions, if you imagine this is like sitting on a table, you could have another vector sticking straight up that is 90 degree to both. So I could draw little 90-degree angles right there. Now this would be called my orthogonal vector. So orthogonal means the same thing, but it's there because you could think about perpendicular in more than 1 dimension, in 3 dimension. But for now, I'm just going to show you one thing to notice here. If I take this formula, this is what we were just using to find the angle between 2 vectors. Now, what if I took these 2 vectors here? I'm just going to say this one is 1, 5, and then v is -5, 1. So the first thing I do I've done before is I would dot product them. So 1 times -5 is -5, 5 times 1 is 5, and then I would add those numbers up and I would get a total here of 0. Now the thing is, if I put 0 on top of this fraction, it doesn't matter what's on the bottom, 0 divided by anything is still 0. And what happens then is cosine of theta is just 0. So again, it doesn't matter what's on bottom. If the dot product is 0, then this is true. Now when is cosine of theta 0? That's when theta is 90 degrees. Or it could be 270 degrees, but I mean, there's 90 degrees and then 270 degrees. So really, all it's saying is that they are orthogonal. So here's the fact. If u dot v equals 0, they are orthogonal. That means they're perpendicular, they're 90 degrees from each other. So, if you want to test it, all you have to do is dot product them. If the dot product is 0, you know they're perpendicular. If it's not 0, you would have to use this formula to figure out the exact angle because it's not 90 degrees. So it's just a shortcut to see if they're orthogonal. So, here's another try problem. So I'm just going to say these instructions. I'm going to put down a bunch of vectors, and it's your job to figure out which of these vectors are orthogonal. So take a moment, pause the video, and see if you can figure out which ones are orthogonal.